Good afternoon, everyone. Let's get started. My name is Ganesh Srinivasan. I'm a program manager in the Windows Azure networking team, and I'm really excited to be here to talk to you all about all the investments we've made in Windows Azure. But before I get started, I just wanted to get some background on about you. So how many of you have had prior experience with Windows Azure and other cloud platforms other than Windows Azure? Great. So it looks like there's a healthy mix of people who've used Windows Azure in the past and those who've not done anything with Windows Azure in the past. So the objective of the session is to basically give you an overview of all the investments we've made to make Windows Azure a great platform for you to do your prototyping, development, and test efforts. So the focus is going to be primarily on that. And I've intentionally made it a very demo-intensive session to just give you an idea of how easy it is to actually do these things. All the demos that I'm going to be showing you today are stuff that I actually can start and finish in the time that we have today. So there will be, these are going to be very easy for you to, look at and actually try them out. In fact, some of the demos that I'm going to be showing you here today are parts of the exercise that, we have a competition that's going on. And some of the steps that I'm going to walk through here are parts of that competition. So you can actually learn from this and try it out yourself. It's pretty easy to do these things. So that said, let's get started and let's talk about, let's see what all we're going to talk about today. How many of you have actually had to, set up prototypes in the past and have had to wait for weeks or months to procure hardware and wait for them to be set up and, before you could actually start your project? So I'm sure I see a lot of people raising their hands and, that's typically frustrating. And, the cloud is a great place where you can actually avoid the wait time. So if you wanted something, you could just go spin up something on demand, use them, and tear them down when you actually don't need them. So I'm going to be talking about the investments we've made specifically around virtual machines to enable you to do these kinds of setup and tear downs really fast. We're then going to talk about some of the offers that we have that we've put together specifically for dev test scenarios, and we've tied it to our MSDN subscriptions. And then I'm going to talk about a lot of things around hybrid networking. So being from the networking team, it's a topic that's dear to my heart. I'm going to be spending some time talking about technologies that enable you to connect to your deployments in the cloud without having to go through the public internet, or at least connectivity through the public internet to basically do your dev test scenarios. And I'll then wrap it up with some of the demonstrations. I would show you a couple of demonstrations on how you could use all the technologies we talked about together to actually realize your dev test and lab goals. So let's get started. So basically, what does the cloud offer you, and why is it that you should consider Windows Azure? First of all, it's pay-per-use. So if you needed resources, you don't have to purchase hardware in advance, wait for it to show up, rack it up, and actually set them up. Whenever you need computing resources, you just go to the cloud, you sign up into the Windows Azure portal, log in, and actually procure and start virtual machines in a matter of minutes. And what's cool is that we've announced certain new capabilities. The first thing is the fact that instead of billing you per hour for virtual machines, we actually start billing you per minute. So we only charge you for the minutes you actually use your compute for, and that's actually going to help you save a lot of money. The second thing we've done in terms of enabling you to save money is the fact that we've introduced this MSDN subscription offer where for dev test scenarios, we actually charge you a nominal amount for compute resources that you spin up in the cloud. When you talk about dev and test, it's all about automation. So we've got a whole bunch of tools and a lot of PowerShell scripts that we put together as samples to enable you to actually script and get your virtual machines up and started as soon as possible. And you could do a lot of cool things with PowerShell. I'll show you one or two tricks during this session. It's also easy to actually capture services or virtual machines that you create and replicate them using these automated tools. In addition to PowerShell, we also have command line tools for other platforms as well. And then we have networking support primarily around hybrid, and we also have a load balancer service that's built into every cloud service. So you get load balancing for free, and you get the ability to actually connect to your services in the cloud from your premises and do everything. And in fact, we've introduced a new service called the Virtual Network Point-to-Site Connectivity Solution that enables you to connect from anywhere behind a NAT or a firewall or a proxy to your machines in the cloud without having to actually go through the public IP addresses for your cloud service. So we'll talk a lot about that and see how it comes in handy for dev test scenarios. So basically, if you are going to be in large organizations where there are IT administrators, and there are different ways in which you can actually manage your Windows Azure subscription. We have a Windows Azure portal that's basically built on top of the REST APIs that we'll talk about in a bit. And this portal gives you the ability to create and manage all your compute services, all the services that we have in Windows Azure. We also have rich scripting support. We have support for PowerShell, as well as for other cross-platform tools. We have command line tools for Linux, Mac, as well as for Windows. In addition to that, all these tools are actually built on top of a REST API surface that we actually document and publish. So if you don't want to script and you actually want to code directly to it, you can actually use our API reference that's published in MSDN to actually manage all the resources that you have in Windows Azure. And a typical example of what you can do is our Windows Azure portal. The Windows Azure portal is actually an application that calls all the publicly documented APIs that we've released in MSDN. So whatever the portal can do, you can actually easily do it by yourself using either PowerShell or REST APIs directly. Now, when we talk about dev test and when we talk about infrastructure services, we really thought hard in Windows Azure, and we wanted to give you a feeling where we supported a large set of services and servers that we offered in Windows Azure. Now, basically, we work, as part of Microsoft, one of the key value props that we thought about was the fact that any server product that we have in Microsoft should work in Windows Azure. And what we've done is we've actually worked with each of the product teams here to actually do a joint validation exercise. And we've made sure that, for example, SQL Server in this case has different server SKUs that are published there. So we worked with the SQL Server team very closely to validate a bunch of workloads that we standardized, and we made sure that our support team will support you end-to-end on any of these workloads that we've listed here and the server SKUs we've listed here. So if you wanted to actually deploy a database server, you could pick from any of these SQL Server database options that you have in the platform, deploy it, and if you run into issues, typically this is a case where if you're using SharePoint, supporting SharePoint is actually a hard thing. And if you set up SharePoint and other cloud platforms, it's typically split between, SharePoint support is handled by Microsoft and the cloud support is handled by the cloud provider. We've tried to simplify that and offer you a single point of contact where the same team will actually support you through SharePoint as well as Windows Azure. So we've tried to make sure that all these organizations talk together and try to make the experience of setting up, managing, as well as support for those products integrated, so you can actually get the most out of the product. In addition to Windows and Microsoft products, we also have a set of Linux distributions that we support in the platform. So our platform in Windows Azure is open, and it's actually based on the Hyper-V Windows Server 2012. Our entire platform is built on that, and it really scales really well. So we've worked with certain partners in the open source space to actually have their distributions validated against the Windows Azure platform. So Ubuntu, OpenSUSE, and CentOS are worth mentioning here. So when we talk about infrastructure services, Azure was historically a platform as a service offering, and typically we were working on offering solutions where we assumed that compute was stateless and pretty much all state resided in some sort of a storage mechanism. But for infrastructure services, the virtual machines themselves are stateful in the sense that you have OS disks and data disks that have state associated with them. And we had to make certain design decisions when we actually went into supporting infrastructure as a service. One key thing that we decided was we wanted to offer customers mobility, and we wanted to use an open standard for actually hosting virtual machines in Windows Azure. So we actually chose to use the VHD format for storing virtual machines in Windows Azure. So if you're used to running Hyper-V virtual machines on premises, you could actually take the same VHD files that you have for your virtual machines that are running on premises, take a snapshot of that, copy them over to your storage account in Windows Azure, and start a virtual machine in Windows Azure. It is as simple as that. There doesn't have to be any format conversion or anything special that you have to do to your virtual machines to get them started in Windows Azure. So that was one of the key decisions we made. The other key decision that we had to work on was in providing you with a highly available storage solution to host your VHDs on. Now, we'd spent a lot of time working on Windows Azure Storage, and Windows Azure Storage is a highly available platform. To give you an example of what actually happens, every block of data that you write into Windows Azure, we actually, under the covers, make 3 copies of it and store it in the same region. We also have the option of doing geo-redundancy, so geo-replication. So if you chose an option to enable geo-replication for your storage account, we actually geo-replicate your entire storage contents asynchronously to a geo-replication pair site. So typically, if you were in the US, we have US East and US West mapped as geo-replication pairs. So if you hosted your storage account in the eastern part of US, we actually automatically, under the covers, replicate it to US West and make sure the chance of data loss is minimized significantly. And the other key decision is the fact that the VHDs that you copy over to Windows Azure are mounted directly into our storage stack. So if you're actually reading and writing to databases and things like that, our storage stack is heavily optimized to handle those kinds of workloads. The more the I/O requests that you make to our storage stack, the storage stack performs a lot better. And our storage stamp is not a SAN. It's actually a giant set of clusters that we run in Azure. So imagine a giant SAN array where we've actually striped to thousands of disks. So your read writes are completely distributed across our storage cluster. So you get a lot of good performance and very high throughput numbers when you read and write to disks. So I'm going to now move to show you a quick demo of what Windows Azure is, how easy it is to create a virtual machine in Windows Azure, and what you can do with basic PowerShell scripting. So for those of you who are new to Windows Azure, this is the new Windows Azure portal. We released it last year, and it gives you a single pane of view of all the services that we offer in Windows Azure. We offer websites, compute in the form of virtual machines, and cloud services. We have databases, storage, networking, media services, and so on. We'll focus primarily on virtual machines, cloud services, and networks today for the rest of the session. So when you log into the portal, you get a list of all the resources, the virtual machines, the storage accounts, the networks, and so on that you've created in your subscription, and you can go and manipulate them. So the first thing I'm going to show you is how easy it is to actually create a virtual machine in Windows Azure. So for that, I'm actually going to log into a subscription that is not as noisy as the one that you actually saw previously. Now in this case, I'm going to create a new virtual machine in Windows Azure. You click on the new button here, select compute, virtual machines, and you have an option of doing a quick create, which just shows you a few options, and it creates a virtual machine very quickly. The other option is to go and create a virtual machine from gallery. And this is where you actually see a large list of virtual machines, or the VHDs that we've uploaded into the platform. As you can see, we have Server 2012 and the latest version, Server 2012 R2, available for you to try out. So if you actually wanted to try out Server 2012 R2, you don't have to copy the VHD and start a machine on-prem. You could just create a virtual machine in your subscription in Windows Azure. So let's just do that. So you select the image that you wanted to create for your virtual machine. Give it a name. You can pick the virtual machine size that you want for Windows Azure. So we have about 5 or 6 standard sizes that we offer. We have small, medium, large, extra large, and then 2 high memory SKUs that are available. Those are really new. The A6 and A7 sizes you see are higher memory SKUs. Typically, for databases and applications that require a higher memory to processor ratio, you could pick one of them. and create a virtual machine in Windows Azure. Now, for the sake of this demo, I'm going to create a small virtual machine. I pick the size. I give a username. And then I get to specify a cloud service name. So typically when we create a virtual machine in Azure, we assign it a public IP address, and that's the way you reach it. And we actually map the public IP address of the virtual machine to a DNS name, which is the cloud service name. And we actually make an entry in the Azure DNS service. So typically, whenever you create a virtual machine or a cloud service in Azure, you have to give it a cloud service name. So I've given it a name. And I'm going to create a virtual machine. So I actually have to place the VHD into a storage account. So what actually happens at this step is you've specified the image that you wanted to create a virtual machine from. And when you specify a storage account, we actually do a copy of the VHD over into your subscription storage account. So in this case, I have a storage account called TechEd EU that I've already created. And that's in the North Europe region. I specify that. And we have an option where you can enable remote PowerShell right from the get-go. So we've enabled WinRM by default. At the time of provisioning, we set all the properties up so that you can actually manage the virtual machine using PowerShell right from when you've deployed the virtual machine. And as you click through this wizard, at the end of the wizard, you've actually started provisioning a virtual machine in Azure. So we do a shadow copy of the VHDs over from our account into your Windows Azure storage account, and then we mount it as a VHD and start a VM in Windows Azure. It goes through the out-of-box experience in setting up a Windows server. It takes about anywhere between 3 to 6 minutes to have your virtual machine set up and ready for you to log on and use it. So I actually pre-created a virtual machine just before we got here, and I'm going to show you how easy it is to log into that virtual machine. So this is a Server 2012 R2 virtual machine that I pre-created. You could just go down and say connect. It's going to give you an RDP client. It typically lists a box where you enter your credentials, and once you enter your credentials, it logs you in. So at this point in time, the virtual machine is fully set up, and once you log in, it just looks like your desktop, and you can do whatever you want. You can install any applications you want, mount data disks, do whatever you want to get it going. So I think it's slow because of the network bandwidth that we have out here, but that gives you an idea. So once you remote desktop, it's like your desktop. You can do whatever you want. Now, when I talked about it earlier, I talked about the fact that you could actually, here it goes. We bill you only for the time you're actually using the compute for. In the past, what we did was, even if you shut down your virtual machine, it was hogging resources because we had to reserve resources for you in our compute clusters. We've actually made changes so that when you actually stop your virtual machine, we release these resources. So we don't charge you for when you stop your virtual machine. So let's say you're prototyping something, and you've set up a virtual machine in Azure, and you've set up a Server 2012 R2 virtual machine just to try out and see what it offers for you. And you only want it to be charged. You want to be charged only when you're using it. And let's say at night you're not planning to use it. You want to shut it down. If you shut it down, we will not charge you for it. So once you click on shutdown, the virtual machine actually goes to this stopped deallocated state. When you're in that state, you can rest assured that we do not charge you for compute for the time where we've completely shut down. And when you start the virtual machine, in this case, I've stopped a domain controller for an example. When I start it again, it's going to create the virtual machine again. It's going to mount the VHD associated to the processors that we've reserved for it, and then start the virtual machine. So it's like rebooting the virtual machine from the VHD you've stored, and we start billing you from the time it's ready for you to use. So that saves you a lot of money in the sense that we charge you for the minute. So if you've used it for 45 minutes, we charge you for 45 minutes and not for the entire hour. And once you stop it, we don't bill you for it. So these two will help you save a lot of money when you use the platform. Now, when you do dev test kind of scenarios and you've set up your virtual machines, in some cases it takes a long time to set up these virtual machines, and some of your tests may be destructive. So you may want to capture those virtual machines and have a copy of them so that you can, if you, for some reason, did some destructive testing and you wanted to get back to a last known good state, you have the option of doing that. Now, we have a PowerShell script that you can actually download from our download center, and that enables you to do that. I'm going to show you that in just a minute. But taking a snapshot is just a matter of a few seconds in the platform. I'll show you how to do that next. Now, for the sake of this demo, I'm going to move to the other subscription I have, and I have a lot of virtual machines here. The virtual machine that I care about most is this test VM2. If you look at the property of this virtual machine, I have 2 disks in this virtual machine. I have an OS disk that was actually copied from a platform image that I created. And to store data, I actually created a data disk and attached it to that virtual machine. Now, let's assume this had your test code and you spent hours setting up this configuration that you don't want to lose. You can take a snapshot very easily. And I'm going to show you how to do it using PowerShell. So PowerShell is actually our way of scripting, and we've added PowerShell support for Windows Azure. What we did was we actually wrote a layer that actually called REST APIs under the covers, that the REST APIs that we published in MSDN, and it helps you, script very easily. Now, in this particular case, the example that you see up here actually sets up the environment. The first command says import the PowerShell module. You can download it from the Windows Azure website and actually install it. Once you've installed it, you've got to actually import the PowerShell module, and that enables you to actually call all the PowerShell commandlets that we've created for Windows Azure. Once you've done that, you need to authenticate your machine with the Windows Azure subscription. So for that, you actually have 2 ways of doing it. You can either upload a management certificate and use the certificate thumbprint for authentication, or you can actually go to your Windows Azure portal and download a published profiles file that actually has your certificate thumbprint and all other information that I need to know about your subscription. So I've actually downloaded that file, and I've stored it in my machine. And since I have a lot of subscriptions, a subscription in Windows Azure is actually a billing entity, and you actually model resources against your subscription. So if you have multiple subscriptions in your account, you can specify the subscription either by subscription ID or by name. You select the subscription, and you select the storage account that you want to use in the subscription if you had many storage accounts. Now, in this case, the first 4 or 5 lines of the script purely does that. And then the next line here says, capture this virtual machine called test VM2 that's in TechEd demo test US West, and store it in this TechEd demo US West storage account, and create a container called snap. Okay? So once we run this PowerShell command, it's actually, what it's doing under the covers is actually authenticating myself first, and it's going to actually make a copy of the VHD files here. If you look at it, the first file here is the OS disk, and pretty much the last file you see here is the data disk for that particular virtual machine we created in Windows Azure. Now, I ran the PowerShell commandlet, and it succeeded successfully. It completed successfully. And if I went and refreshed my storage account, I actually see this container, new container called snap that's created. And if you look at it, it's actually copied the virtual machine over as is in a matter of seconds. It's got a full copy of the OS disk and data disk copied into this container. So you can do whatever you want with your virtual machine, and you can rest assured that we're not going to destroy it. So even if you destroyed it, you have a backup copy from which you can restore the virtual machine completely. So this is just to illustrate what you can do with PowerShell in Windows Azure. So there are a lot of scripts that we write and a lot of people out there write. You will find a lot of them made available to you through GitHub, and we're also going to have a portal in Windows Azure from where you would be able to download these sample scripts, customize them, use them, and if you feel like others could benefit from it, you could contribute to that as well. Now let's talk about availability. This is a key aspect. So typically, once you move from your dev test phase to a production phase, you want your services to be highly available in Windows Azure. And typically, when you run them in clusters and in your data centers or our data centers, there are a lot of single points of failure. One single point of failure could be the power distribution unit to that rack, or it could be the top of the rack switch for that complete rack. So if we lose the top of the rack switch due to some hardware issues, or if there was a power failure to the entire rack, you shouldn't suffer from a loss of service. So typically what we do is we ask you to deploy multiple copies of the same service in Windows Azure, or multiple copies of the same virtual machine in Windows Azure, and put them in what is called an availability set. So let's say you were building a web application and you used the IIS server as your web front end. Instead of creating one front end interface, a virtual machine, we'd ask you to create at least 2 virtual machines for your front end and put them in what is called as an availability set. Once you put these virtual machines in an availability set, we know that they are going to be performing the same role and that they will have to be highly available. So our placement logic makes sure that they are placed in different fault and update domains in our data centers. So they get independent power and independent network connectivity for that particular rack. In addition to that, when we do updates in the data center, we keep our infrastructure up to date. We make sure that we don't take them down at the same time. So that way your service is always available even if one of the virtual machines is down for some unknown reason. So you've created these 2 virtual machines, and you actually want to make it highly available to the customer. So typically what you would do is you would set up a load balancer in your premises. You would typically have a big IP device from F5 or a Citrix NetScaler device or something similar to that, and configure it to load balance your application between the multiple instances that you have in your premises. Now in Azure, when you create a cloud service, the cloud service comes built in with a load balancer that we run. We run a multi-tenant load balancer service, and that load balancer service automatically gets configured when you create these virtual machines. You get to define what are called endpoints, and these endpoints are typically grouped together. So typically, let's say you're building a web application and you wanted to open up the HTTP traffic to those virtual machines, you would define an endpoint on TCP port 80. That way, we configure the load balancer saying, hey, these 2 are the virtual machines. In this case, VM1 and VM2 are performing the same task. Open up port 80 in the infrastructure and also load balance between them. So if you're getting 1,000 requests, based on the flow, redirect them to the appropriate front-end server. This way, you can distribute your load evenly across how many ever instances that you've spun up, and they're always highly available. So it's extremely easy for you to build a highly available, scalable application. There's actually a talk on building resilient applications in Windows Azure. It's on Friday at 8:30 in the morning, where we talk about best practices, guidances on what all you should be aware of when you actually think about taking an application from dev test to production, what you have to think about in terms of disaster recovery, high availability, clustering, failover, and so on. So if you're interested in running production applications in Windows Azure, I'd recommend you to attend that session. So we talked about economics and we talked about pay per minute. So traditionally in other cloud providers platforms, and when you're doing dev test in particular, you don't get to use it for full hours. So if we charge you for the minute, you get to save a lot of money, and we don't round it up. So you actually get to save. If you look at this graph is to show you a rough example of a VM that gets used sporadically. And as you can see, there are a lot of areas where you don't get to use the VM much. So in that case, you get to save and not pay for all the minutes that you've not used the virtual machine for. So per minute billing is going to help you do that. The other thing that I showed you and that we talked about was the fact that when you stop your virtual machine, we actually still continue to bill you. Now, with this new capability that we've introduced in the platform, we deallocate the resources. So that gives us the ability to not bill you when you've stopped the virtual machine. So you have the VHD stored in your storage account. You pay for storage, but you don't pay a recurring charge for compute when you've stopped the virtual machines in Windows Azure. So let's talk about MSDN. So how many of you here are MSDN customers or MSDN subscribers? Wow. How many of you have used Windows Azure or used your MSDN subscription on Windows Azure? Did any of you start using it in the last few weeks when we made the announcement? Cool. So basically, we had a very complex way, and there was a very hard way to figure out what you get as credit for having an MSDN subscription. We've decided to simplify it significantly and offer you just 3 plans. There's a professional premium and an ultimate, and you get X dollars worth of money credited to your account that you can use against any Windows Azure service. That's the first thing that we did to simplify your MSDN account usage. The second thing that we did was the fact that we actually reduced prices for compute significantly. So this becomes more attractive when you look at new workloads that we introduce, especially in the form of BizTalk. We charge you more than $2 per hour for using BizTalk in Windows Azure or a large SQL server in Windows Azure. Now, if you're trying to do a prototype or a dev test kind of a scenario, we just charge you 6 cents per hour for using the same SQL server. So we don't charge you the full rate if you had an MSDN subscription for doing prototyping work or for doing dev test work in Windows Azure. So for those who don't have MSDN accounts and for those who've not been using MSDN accounts for dev test, this should be a great motivational factor for you to actually use the MSDN account for dev test. It's going to help you save a lot of money. So between per minute billing, stop billing when you stop virtual machines, and the MSDN offer, it's actually a very great platform for you to actually consider for doing your dev test work. So now I'm going to switch over and talk about hybrid. And hybrid is a buzz term that's been thrown around a lot. I'll define what I mean by hybrid for the context of dev test here and talk about the offerings that we have in Windows Azure. So traditionally, when we talk about hybrid, it could mean a lot of things. But the way we look at it is actually building and running services that are distributed across different geolocales or different regions and locations. You could have a multi-tier application where your front end sits in one region and your back end sits in another region, or you want to move your data back and forth between regions. And you want to just cobble up services together to get them to work. And there are different ways in which you can do that. One is to actually migrate data back and forth. There are several options, one option being the SQL Azure Data Sync that enables you to synchronize your databases between SQL Azure and your on-prem databases. We have a solution called Service Bus that's a pub-sub model. So if you're writing your own application and you want it to be truly agnostic of the location, you could use the Service Bus. But if you've already written an application or you're running a virtual machine like SQL Server or something like that, you don't have much control. You need connectivity at an infrastructure layer between wherever you are located and your services that you run in Windows Azure. For that, we have 2 solutions. One is called Windows Azure Virtual Network Site-to-Site. And last month, we introduced this new service in preview called Windows Azure Virtual Network Point-to-Site. Now, point-to-site is a technology that I'm going to talk about a lot today because that's primarily targeted towards making life easy for dev test scenarios. So what this is VPNing into your virtual network that you have in Windows Azure without actually having to worry about where you're located. So you can actually sit in a coffee shop or anywhere behind a proxy or a firewall and have full private IP level connectivity to your services that you have in Windows Azure. We'll talk about how easy it is to set up and how you can use this to connect from, let's say, a Visual Studio machine to your deployments in Windows Azure, get metrics, monitor your services, and do a lot of stuff. I actually have a session on Friday where I talk about just the hybrid options we have in the platform at great detail. So I just talked about the fact that virtual networks enables you to connect your premises to the cloud. We have a site-to-site option that enables you to extend your on-prem infrastructure to the cloud. Let's say you're building a line of business application. You want to do initial testing in the cloud, but your line of business application has a dependency on your on-prem domain controller or your SCOM server or any other service that you have in your premises. You could actually extend your premises to the cloud using this site-to-site solution by actually using a VPN device in your premises and extending your network into the cloud. Now, when you have extended your network to the cloud, you can actually download a VPN client for your network in the cloud and connect to your network using that VPN connection. It's extremely easy. One of the demos I'll be showing you later today will be on setting up this point-to-site connectivity in Azure by just clicking through a wizard in the portal. And then we'll do some fun stuff with the point-to-site connection that we set up. So this is going to be extremely easy because for the site-to-site, we used industry standard IPsec VPN to connect your premises to the cloud. And for point-to-site, we actually chose a protocol called SSTP. It's Secure Sockets Tunneling Protocol. So for all NATs, proxies, and firewalls out there, it would look like an SSL connection. It would look as though you're connecting to an e-commerce site or something through SSL, but it's actually a bidirectional channel through which we tunnel traffic through. So you could be sitting anywhere and have a private IP connection to your virtual network in Windows Azure. We just talked about it, and this is just a diagram to show you how it could typically look like. One of the things we did was we wanted to eliminate the need for having hardware devices to set up site-to-site connectivity. So we worked with our Windows team to enable Windows routing and remote access service as a VPN device. So you could actually go to the portal, download a PowerShell script from the sample page in our portal. I'll show you where it is, and run that PowerShell script in a server or a virtual machine and make it an RRAS server. So you have a site-to-site connection that way. And you download a VPN configuration package. It's not code. And that configuration package uses an inbox VPN client to configure the point-to-site connection. And you could be anywhere and connect to your services running in the cloud. So from this point in time, I'm going to move to a demo mode where I'm going to show you a few things. I'm going to show you how easy it is to set up this point-to-site connectivity and a virtual network in Windows Azure. I'm going to show you how you can deploy virtual machines into them. The next thing I'm going to move on is to show you how you could take advantage of this point-to-site connectivity to do some simple development work. I'm actually going to show you a virtual network in which I have a SQL server running that's being used for a SharePoint farm. But I'm also going to use a test database sitting in that SharePoint farm, and I'm going to debug my front-end code. And then I'll publish that as a PaaS application. So you'll see how infrastructure as a service and platform as a service can work together to offer you scalability. For the test perspective, I'm actually going to show you how you can actually do a SharePoint load test or something similar to that using this point-to-site connection. So let's get into these demos. So for the demos, I'm actually going to be using, for some of the demos, I'm actually going to be using a SharePoint farm that I actually created. I'm not a developer and I'm not a SharePoint expert. I'm just a plumber who understands networking. And it took me about a weekend to understand what SharePoint does and how to configure it and set up all the demos I'm going to show you today. So it's not that hard for you to figure out what it does and actually read through the documentation to set it up. So if you're really interested in what you can do with the platform, following these instructions in GitHub and actually setting up a SharePoint farm would give you a good idea of what it takes to set up a multi-tier application in Windows Azure and do debugging to it or do some load tests on it. So we are in the Windows Azure portal right now. So I'm going to show you how to create this point-to-site connection and a virtual network in Windows Azure using the wizard that we support in the portal. So just the way we created a virtual machine, you could actually go and create a virtual network in Windows Azure. So there are different ways in which you could create a virtual network in Windows Azure. The first thing is to go through a wizard and click through all the screens in the wizard, and you'll have a virtual network created. The second option is to actually use the schema that we published, come up with an XML definition of your entire network, and upload it into your subscription. That would create a virtual network as well. So let's use the wizard to actually create the virtual network. So I'm going to create a network. It's like a private network that I run in the cloud. There are a lot of advantages to actually running a private network in the cloud. One of them being it gives you isolation from others in the network. You can build shared services. For example, if you're building multiple cloud services that all have to use a shared database, you can put all of them in a virtual network. So they are all within the same trust boundary. They can talk to one another. They give you IP address persistence. So when you create a virtual machine, we assign it an IP address, and the IP address stays with the virtual machine. So there are a lot of benefits to actually creating a virtual network in Windows Azure. So for you to create a virtual network in Windows Azure, you need a set of IP address blocks. And these blocks are what you provide in this wizard. I'll talk you through what it takes to create a virtual network. So for this demo, I'm actually going to create a virtual network in one of the European regions. And I'm going to actually give it an IP address pool. And I'm also going to give it another IP address pool from which it has to assign IP addresses to any VPN client that we connect to that virtual network. So let's go through the wizard and see what we can do. So I'm going to create a network. And when I create a network, I'll have to place it in a region. And I want to group a whole bunch of services in the same region. So for example, I may have storage accounts. I may have multiple cloud services running there. I want to place them all together. So for me to tell Azure that I want to group all these things together, I'd have to create what is called as an affinity group. And the affinity group gets pinned to a region. So for this case, we are going to create a new affinity group. And we are going to say that the new affinity group goes into North Europe, which is our Amsterdam location. I'm going to give it a name. And if I have more than one subscription, I can specify which subscription it goes into. I'm going to put it in my demo subscription for now. So you have an option to configure DNS servers. I'm not going to talk about it today. If you want to know more about what you can do with name resolution, I'd urge you to come to the session on hybrid, where I'll talk a lot about all the options in great detail. So we are interested in creating this point-to-site connection right now. So I'm actually going to check this option where I can create point-to-site in the portal. So you will see a diagram at the bottom of your screen that shows you what it typically will look like. In the next screen, I get to specify the IP address range that I want to use for my VPN client. I can have up to 256 VPN clients that I can use, from which I can connect to this virtual network in Windows Azure. So if you're an organization where you have a couple of hundred developers who want to do some rapid prototyping, you could actually create a virtual network for them in the cloud and have them connect to that virtual network through VPN. And we set a limit of 256 today. So for assigning IP addresses for these VMs, we actually have to specify an IP address range. And in this case, I'm going to use the 10.0.0 IP address range for these VPN clients. Then I get to specify the IP address range for the virtual machines that I place in the virtual network. So this is where you specify the address range, and when you create a virtual machine, we pick an IP address for that virtual machine from this IP address pool that you've specified. So if I wanted to create tons of services, let's say I wanted to create a couple of hundred services, I'm going to use the entire 192.168 block. I'm going to have 256 IP addresses that I'm going to use. And within that, I'm going to partition the address spaces. If I'm building a lot of applications, I could do it based on applications, or I could do it based on tiers. So I'm going to basically carve out some address spaces for various tiers. I'm going to have one for front end. I'm going to use one for back end and so on. Now, in addition to creating these subnets, you need connectivity. For connectivity, what we actually do is we deploy a pair of VMs into your virtual network, and they act as your VPN gateways. We actually deploy 2 VMs in active passive mode so that they are highly available and that they are fault tolerant at any given point in time. And we configure Windows Server routing and remote access service within them automatically. So for us to be able to place those 2 virtual machines in your network, you would have to provide us with some IP address ranges. So for that, you would have to actually create a gateway subnet within your network and give it IP addresses. We need 2 IP addresses for that, but we suggest you carve out a /29 subnet for that. And with that, you've actually created your virtual network in Windows Azure. Creating a network is as easy as clicking through these few screens in the portal, and your network is ready. We created this network that you can view the state of. Now, you've created the network, but you don't have a gateway running yet. So at the bottom of the screen, you could come and say, create gateway, and say yes. What this does is this deploys the 2 VMs as your gateway and configures RRAS servers within them. So it takes about 4 to 6 minutes, at the end of which you have a gateway ready for you to use. Now, let's move on to another subscription where I've actually configured the gateway and that's ready to use. So I called it BRK Lite because the project was codenamed Project Brooklyn. The site-to-site connection project was called Brooklyn, and we decided to call this point-to-site Brooklyn Lite. So that stuck, and I called it Brooklyn Lite. Now, when I configured this virtual network, I configured it as both a site-to-site as well as a point-to-site connection for this virtual network. I used an RRAS server to actually set up my site-to-site tunnel. And for that, all I had to do was go to the portal, click on the download VPN device script. We support a whole bunch of platforms. You could select the platform and say OK. In response to that, we actually give you a PowerShell script, and you could just enter certain parameters that we ask you to enter and run this PowerShell script in the Windows Server 2012 box that you want to configure as your site-to-site VPN. So by just running this PowerShell script, it sets up everything to run RRAS in your virtual in your machine, and also configures the tunnel for that. Now we're going to talk about point-to-site. So you want to be able to RAS in or connect in from your machine anywhere to your virtual network. So for that, I have to know who you are, and the way we authenticate you is using certificates. So we ask that you actually generate a self-signed root certificate and upload the public key of the root certificate to us. We have instructions on how you can generate these certificates. You can use the Windows SDK and a tool called MakeCert that's built into Windows SDK to generate these certificates. You upload a root certificate to us, and you generate multiple child client certificates from the root certificate. Now, for every client that you want to connect, we recommend you have a child certificate generated from the root certificate. So we validate the certificate chain, and we know that it's you and you're a trusted person that can connect to this network. So once I generate these certificates, I can actually upload the certificate into my subscription. So you should be able to upload the certificate into your subscription and then download a VPN client package. So once you've uploaded the certificate, it's the SIR file, you'll provide it using an upload thing. And when you click this thing, you would be able to download the VPN client. And what the VPN client contains is not code, it's configuration. It basically specifies information on what your VPN server in the cloud is. It pushes a certificate for server-side authentication and sets up the environment. So in this case, I'm running the VPN client package. So I'm installing the VPN client, and it's done. So the VPN client has been installed in my box. And if I click on networks, you actually see the virtual network name listed here as a VPN client. And all you have to do is click on connect. It opens up a standard Windows VPN client package, and you click on connect. This uses the certificates, authenticates, and you're now connected. So I'm actually from this demo machine connected to my virtual network in Windows Azure. So it says connected. Now, in this virtual network, I have a lot of virtual machines. I actually have a SharePoint farm running in there. So we can actually connect to all these virtual machines using their private IP addresses. So just to show you that, if you look at here, the SQL server's IP address is 10.0.2.4. It's obviously not internet routable. I'm able to TS into this virtual machine through this private channel that we actually set up. So I have full access to this database. This database is not exposed to the public internet, and I can do whatever I want with this database. So setting up point-to-site connectivity is extremely simple. Now let's move on to the next phase, where I'm actually going to show you how you can use it to actually build applications. I want to highlight two facts. The first fact is the fact that you have this private channel through which you could actually exchange data between your premises and the cloud, between your dev box and the cloud. And the second thing I want to highlight is the fact that once you've built your application, you could actually push your application as a PaaS service into your virtual network. A PaaS service is highly scalable. So if you're building a web front end that talks to a SQL Server database in the back end, you could actually publish them as web roles into Windows Azure and have them talk to the back-end database, the same SQL Server database. So you can have IaaS and PaaS mixed together to get the most out of our platform. So that's what we're going to do next. For that, I'm actually going to use Visual Studio. So I already have an application that I wrote. It's a simple application that reads and writes few options into a table in the database that I just showed you that's running as a virtual machine in Windows Azure. Now, all I had to do was, in my connection string, I had to specify the private IP address of the virtual machine that's my database and provide it with all the credentials that I needed to set up the connection to the database. And I have this application here, and I want to debug it. So first what I would do it is run it as a local web application in my local machine to see if the application actually works. So it's building the application. And it's actually running a local copy of IIX Express in my machine and running this web page in it. Now, all these items that you see that it's going to list are actually stored in the SQL Server database that we have, that we just saw. So if I could actually go into the database, click on the items table, and say select top 1,000 rows, you're actually going to see a whole bunch of entries that are right here. The web application that's running as test is actually showing the same thing. It's pulling from the database. So what it's doing is I'm running IIS Express on my laptop here. It's emulating the web server, and I connect through this point-to-site connection that I established through all the proxies and firewalls, and I'm connecting to a backend database that's running there. Now I'm happy with this application, and I have an option to either configure IIS and publish this in IIS, or I could actually configure this as a PaaS role. Now, if you were doing it as a PaaS role, you could create a project, make it as a PaaS role, and there's one configuration change that you have to make, which is to specify that this service has to go into a virtual network that you created. So for that, you add this small section called network configuration, where you specify the virtual network name, the role name, which is the role that's going to have your web content, and the subnet into which that role has to go into, so that we assign it a predictable IP address. So once you've specified all these parameters, you could actually emulate this and see if it runs in the Windows Azure emulator in your local box and talks to the database, and then publish it as a cloud service. So the way you do that is debug it. So if you debug it, it automatically opens a Windows Azure emulator in your machine. So in this particular case, it's spinning up 2 instances that I asked it to spin up. And it's setting up the instances and starting them as my web roles. So this page that you see is actually running on the emulator, the Windows Azure emulator, as a web role. And it's going to pull data from the database through this private channel we set up. Now we know that this application actually works and is ready to be published as a PaaS service in Windows Azure. All I have to do is go to Visual Studio and say publish. This is actually going to walk you through a wizard that takes your credentials, asks you to specify what cloud service you want to put it in, where you want to place it in, and how you want to run it. Once you've specified all the properties for the cloud service, all you have to do is say publish. It compiles the code, uploads the code into your storage account, and deploys the service from there. So just before we came here, I actually set up a cloud service and actually deployed the same package in it. I called it TechEd dev. And if you look at the service, it's exactly the same service that we just were playing around with. And it's running as a PaaS role with multiple instances in them. So you can actually publish them as PaaS services, and they talk to the same SQL Server database that's running in Windows Azure. So it's as easy as that. Using this private channel, you could do a lot of manipulations and deploy your services. Now I want to move over and start talking about the test story. People want to do a lot of testing in Windows Azure. As I mentioned earlier, I actually have a full SharePoint farm running in this subscription. I have a SharePoint front end, a domain controller, and a SQL server already set up in this subscription using the GitHub PowerShell commandlet tools that I was talking about. You could use them to set up a SharePoint farm in your subscription. Now, I set up a SharePoint farm and I want to do a load test on that SharePoint farm. I could actually use the load test capabilities built into Visual Studio to exactly do just that. So I've actually created a project that does the load test. And just to illustrate how easy it is, what I'm going to do now is I'm going to add a test first, and then I'm going to create a load test. So I'm going to say I'm going to add a web performance test here, where I'm going to specify the steps that I need to perform. And it's asking me for credentials for the SharePoint farm. So it's actually loaded the SharePoint farm, and it's connected to it. I can perform a whole set of operations that I actually want to do as my load test. So for example, I could load images or change settings or do whatever I want on my SharePoint farm to generate the load that I actually desire that I want to test. Once I've generated sufficient load, and that's my load test for now, just to illustrate this is an example. I've created my load test. And I've pre-recorded 2 similar tests like that. So for the test to run, it needs credentials. So now this test is saved, and I know for a fact that this test will run. It's going to tell me that all these steps actually pass successfully. So you can use this to actually generate a load test. So for that, what you do is create a new load test in Windows Azure. What I'm going to do is I'm going to simulate users hitting this SharePoint form. I'm going to start with 10 users, and every 10 seconds add 10 more users till I reach 200 users, and I'm going to simulate the load of 200 users on the SharePoint form. I have a bunch of tests that I already created, plus the one that we just created. So I'm going to add these 3 tests, and I'm going to use them to generate 1/3 the load. I'm going to simulate a LAN environment, and I'm actually going to use a couple of different browsers to simulate the load. And we've got our test ready to go. Once I fire up the test, you'd actually be able to see results instantaneously, and it'll start plotting all the KPIs and all the data points that you actually care about and give you results instantaneously. In this case, I did not do anything special to add perf mount counters. So the counters you're actually seeing are counters from the test results and from the response times that the test clients are actually generating. But you could use this backend channel to actually specify explicit perf mount counters on every tier of your application. So let's say you wanted some special IIS counters or SQL Server counters or SharePoint counters. You could actually specify the list of counters in Visual Studio, use this private channel to connect to the server and test, and gather these data while you actually hit it with all the load that you want it to be hit with. So it's a very powerful way to connect to an environment that you've set up your prototype, gather all the metrics that you want to use to test it out, and it gives you a good idea of what you can do. Now, in addition to that, before I go to summary, our incubation team actually spent time with a couple of customers to do dev test kind of scenarios, and they've actually documented their experiences in the form of videos. I've embedded them in the slide deck you can download from the TechEd site. They walk you through what all you can do as part of this dev test experience. So just to summarize what we just talked about, I believe Azure is the cloud platform and the real platform where you can do dev test very easily. And we've done a lot of things over the last few months to basically make it the right platform for that. The first thing being, we simplified billing. We charge you only for the minutes you use rather than for the full hours. We don't charge you when you stop virtual machines, so we charge them only when you want it running. We've reduced the cost of virtual machines if you use an MSDN subscription from, let's say, $2 for a SQL Server to about 6 cents for your dev test efforts. We also have various ways using which you could actually connect to these services that you deploy in the cloud using private IP addresses without having to expose these services to the cloud, and control them, manage them, and run them any way you want. So in addition to that, you will actually see a series of investments that we make to the platform to make them better, but this is just a start from us. So I hope all of you got some learning from this, and you will apply this towards your next prototyping or dev test project that you plan to take up. So with that, I'd like to open it for any questions that you may have. So if you don't have any questions, thank you very much. We'll have a lot of people from Windows Azure in the booths. You could stop by and have your questions answered. Thank you.